Hi everyone, this video covers one of the more tricky questions I've seen in an A-level product design paper. This question asks you to use a bit of trigonometry, some Pythagoras. So here's Miss Baker taking us through the method she would use.
Okay, so this table, we've got a hinge like this, which is where we're starting, and then later on we're going to bring the hinge closer together to make the table go taller. And that's our first position, that's our second position. And we're being asked to look at the distance between A and B at the start, the distance between A and B at the end, and then compare those two distances, because look at how much closer it is. So let's start with this picture when the height is 700. And let's work out the distance between A and B. This is symmetrical, so we've got a 60 degrees here, which doesn't make any difference except it means I can write on this side of the page, so I'm not blocking the cut picture. Okay, so for the start scenario, I've got this right angled triangle. I'm going to redraw it out of the way so it's a bit simpler to see. The height of the right angled triangle is 700, and there's an internal angle of 60, and I want to know what's the distance across the top that we can call x, the distance between A and B. It's trigonometry because you've got an angle involved, so if I label the sides, I've got the opposite, the adjacent, and the hypotenuse, but I don't care about the hypotenuse in this question. So I've got O and A, so SO or CA or TOA. I'm going to choose TOA. I'm trying to find A, so I cover it up, which means I've got O, which is 700, divided by T, and T stands for tan of the angle, so tan 60. And if I type that into my calculator, I get the answer 404. I can be more particular with that, but it's actually 404.145. Okay, that's the width between them at the start. Now we're just going to pull the legs closer together. The key thing here, you can ignore this sentence because it's just trying to confuse you. I don't know what they're blabbering about there. But the key thing here is when you pull them closer together, the length of the table leg hasn't changed. And that's really important because otherwise we don't have enough information, because when you pull them closer together, the angle has changed. So we don't know any angles anymore, so we're stuck. So when we look at the new height of 720, if I try and draw that right angled triangle again, I don't know what the angle is. I still want to find the width across the top. I now know that height there is 720, and the important thing is that that diagonal line, the length of that table leg, is the same as the length of the table leg was earlier on. So I need to work out the length of the table leg up here, and I can just copy it here. You can either use trigonometry again if you want to find the hypotenuse, or you can use Pythagoras. People tend to prefer Pythagoras. So I'm going to use Pythagoras with 404.145 squared. It's adding, because I'm finding a hypotenuse, 700 squared. And I'm going to, square root my answer. What have I just typed in wrong? Did I not hit the decimal point? 404 point, I think it's a bit clunky.
It is.
145 squared and 700 squared. That's better. Square root that answer. Okay, so the length of one table leg is 808.29 centimetres. So that is millimetres. So that is that hypotenuse. So I can do Pythagoras on this, but a subtraction question this time to find a shorter side to find x. So the hypotenuse squared, take away 720 squared, and then square root my answer. So the shorter side x is now 367.3325. You're being asked for the difference, how much closer they were. So the difference between 404 and 367. So we've got 404.145. Let's just make sure we use all the decimals just in case we go wrong with any rounding. So 404.145. Take away the previous answer, and I get a difference of 36.812. I'll leave it as that, millimetres, not centimetres.
Well done, madam.
That's better.
Just a reminder again that you can find all of the resources that we've been going through in these videos on the VLE under the VLE task called PD Paper 1. The file's called Example Maths Questions. See you on the next video.